This is question 4 from the Fall 19 final exam. We're given a function f of x and we're asked to find a formula for f prime. Okay. Now, this formula does involve a good amount of multiplication and division. So I've got two choices. I could use a combination of product and quotient rules, or I could use logarithmic differentiation. If I do that, I would have to make a note that the result might or might not be valid at the values that would make f of x equal to 0, because I can't, of course, take the natural log of 0. I'm going to go ahead and do it just using product and quotient rules, and you should be prepared for me to give you something like this and say do it using logarithmic differentiation, or for me to say do it not using logarithmic differentiation. You should know product and quotient rules. You should also know logarithmic differentiation. Okay, I'm going to do this one without. Okay. So I'm going to just say this whole thing is a fraction, so I'm going to have to use quotient rule. So that's going to be low, 3 to the x root x, d high times the derivative of tan squared x, minus, let's see, low d high minus high, tan squared x, d low, derivative of 3 to the x, and I'm going to just rewrite that root x as x to the 1/2 because that makes it easier to take the derivative. All over, square the bottom, and away we go. So I'll get 3 to the x squared. Square root of x squared is just going to give me x. Now, of course, this is a power to a power, so I can simplify that, and I will in my next line to be just 3 to the 2x. Okay, so on top then, I've got 3 to the x root x. Now here we're going to be using chain rule because this is a function composition. I'm plugging tangent into the squaring function, so I'm going to get 2 copies of tangent of x, and then we'll have to multiply that by the derivative of tangent of x, minus tan squared x. Big brackets here because I'm taking the derivative of a product, so I know I'm going to be using product rule. Both terms from product rule are getting multiplied by that negative tan squared x. So I'm going to get the derivative of 3 to the x times x to the 1/2 plus 3 to the x times the derivative of x to the 1/2. That's my product rule. And then on bottom we said we could simplify this to be 3 to the 2x times x. Okay, still have some simplifying to do. Let's see, where's my eraser? This will do, oh, here's a better one. Okay, so I'm going to keep this bottom line up and then just move up to the top of the board to continue simplifying. So we'll get 3 to the x root x times 2 tan x times the derivative of tan x is just going to be secant squared x, minus tan squared x, and then inside these brackets, the derivative of 3 to the x. Remember, with any exponential function, when I take the derivative, I get the exponential function back. If the base is a number other than e, I get an extra factor of the natural log of that base. So this is going to be the natural log of 3 times 3 to the x, and then times x to the 1/2 plus 3 to the x. And then the derivative here would be 1/2 x to the negative 1/2 all over 3 to the 2x times x. Now, at this point, I've evaluated all of the d by dx's. So, depending on what the directions actually said, I might be able to stop here. But remember, one thing that I've said sometimes is that I might require that you don't have any complex fractions, which is fractions within fractions, and that includes not having any negative exponents inside of a fraction, because that's really a fraction. That's 1 over root x inside of that fraction. Okay. So, I don't remember what the directions were last year on the final exam. That was a year ago. But let's suppose that the directions say don't have complex fractions or negative exponents inside of fractions. So that I want to try to simplify this a little bit further. Okay. So, I'm going to come over here. I'm just going to bump that 2 to the very front. So it's 2 times 3 to the x. That is not 2 times 3. That is 2 times 3 to the x. There's no nice way to simplify that. So that stays as two separate factors. Root x, tan x, secant squared x. And now I think what I'm going to do is distribute that negative tan squared x. Okay. So minus tan squared x times the natural log of 3 times 3 to the x times, I'm going to go ahead and just write that as the square root of x. It's not wrong to have it as a fractional exponent here and a square root here, but it's a little weird. Let's pick one and go with it. Okay. All right, and then I'm distributing this to this piece. I am going to bump that constant of 1/2 to the front. So minus 1/2 tan squared x times 3 to the x times 1 over root x. That's what that x to the negative 1/2 is. And that's why we don't like negative exponents inside of fractions, because it really is a fraction within a fraction. All over 3 to the 2x times x. So now, when I have a complex fraction like this, the way to simplify it would be to simply multiply by 1 in the form of root x over root x. Because what will happen is on top, I'll distribute that root x, and when I get to distributing it to this third term, it'll just cancel. So this is going to give me 2 times 3 to the x. Root x will combine with this root x to just give me x, tan x secant squared x, minus tan squared x, natural log of 3 times 3 to the x. Root x will combine with the root x to just give me an x, minus 1/2 tan squared x times 3 to the x, and the root x cancels with the root x on the bottom here. And then on bottom we would have 3 to the 2x times x root x. Don't forget we're multiplying the bottom by root x as well. All right. Do you need to simplify any further than that? Certainly not. Now, could you? Yeah, probably so. There's a 3 to the x in every term on the top. I could factor some stuff out and cancel. Remember, in general, my rule is simplify until you've evaluated all of the derivatives. I might require that you don't have complex fractions or negative exponents inside of fractions. Other than that, you're largely going to be motivated to simplify by what you're doing next. So if we were going to take a second derivative, and I'm rather glad that we're not, but if we were going to, it would be worthwhile to take a look and see, can we simplify this somehow so that our job would be a little bit easier in the next step. On the other hand, if the next thing I was going to do was plug in a number, it might be simplest to stop here, plug in the number, and do my simplification then.